This is a tutorial on the addition and subtraction of rational functions. Adding and subtracting rational functions is just like adding and subtracting fractions. If I wanted to add 5/3 to 1/2, before I could add these I would have to find the lowest common denominator. The lowest common denominator of 5/3 and 1/2 would be 6. So I would have to convert both of these fractions into having the denominator of 6. Now to convert 5/3 into a denominator of 6, I would multiply it by 2 over 2. And I would get 10/6. Then I would add that to 1/2, but I need 1/2 to have a denominator of 6, so I would multiply that by 3 over 3. And then I would end up with 3/6. Now when I add these together, I end up with 13/6. So 5/3 plus 1/2 is 13/6. Well, the same thing works when we're adding or subtracting rational functions. If I wanted to add x minus 3 over x plus 4 to x over x minus 2, I would have to find a way to give these two rational functions a lowest common denominator. And to find the lowest common denominator, I would first have to find the least common multiple of x plus 4 and x minus 2. So now let's talk about how we find a least common multiple. Let's try finding the least common multiple of 32x to the fourth and 6x cubed. Well, one way to find the least common multiple is to take 32x to the fourth and bring it down to its prime factorization. 32 I can factor out into 8 times 4. Now neither of these are prime factors. 8 I can factor out into 2 times 4. Now 2 is a prime factor, but 4 is not. So this 4 I can break down into 2 times 2. These are both prime factors. And then this other 4 I can break down into 2 times 2. And those are all prime factors. So 32 breaks down into 2 times 2 times 2 times 2 and times 2. But we're not looking for the prime factorization of 32. We're looking for the prime factorization of 32x to the fourth. Well, that's exactly the same, except this would be 2 times 2 times 2 times 2 times 2 again, and then times x times x times x and times x, or x multiplied together 4 times. Now let's find the prime factors of 6x cubed. Well, 6 I can factor into 2 and 3, and those are both prime factors. So 6x cubed would be 2 times 3, and then times x times x times x. Now the least common multiple is every one of these factors that are in both of these numbers, but we don't repeat any of the factors. So we would not repeat these two 2's. We would only bring down one 2. Now these other 4 2's aren't repeated, so we have to bring them all down as well. This 3 is not repeated anywhere, so that just comes along. Now 3 of these x's are repeated, so we would bring down just one x for each of them. And then we have this extra x, so that comes down as well. So our least common multiple would be 2 times 2 times 2 times 2 times 2 times 3, and then times x 4 times. Well, 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, and then 32 times 3 would be 96. And then x times x times x times x, or x to the fourth. So our least common multiple for these two numbers would be 96x to the fourth. This works for polynomials too. Say we wanted to find the least common multiple of x squared plus 2x minus 8 and 5x squared minus 5x minus 10. Well, first we want to factor these. X squared plus 2x minus 8 can be factored into x plus 4 times x minus 2. 5x squared minus 5x minus 10, well, I can take a 5 out of there. This will become x squared minus x minus 2. X squared minus x minus 2. That can factor into x minus 2 times x plus 1. Now our least common multiple of these two polynomials is every factor, but we don't repeat factors. So we have an x plus 4, we have an x minus 2, we have a 5, we have another x minus 2, so I don't have to repeat that one, and then we have an x plus 1. So my least common multiple then would be 5 times x plus 4 times x minus 2 times x plus 1. So now let's see how we can use the least common multiple to find the lowest common denominator and add some rational expressions. Here we have 10 minus x over 32x to the fourth plus x squared plus x minus 1 over 6x cubed. Now before we can add these, we need to make them have a common denominator. And the common denominator that we're going to use is our least common multiple. Now we already know what the least common multiple of 32x to the fourth and 6x cubed is. We solved it previously. It's 96x to the fourth. So what we're going to do is we're going to make both of these rational expressions have the same denominator, and that denominator is going to be 96x to the fourth. So how do we make 32x to the fourth equal 96x to the fourth? Well, to make it equal that, we're going to have to multiply it by 3. But if we multiply our denominator by 3, we have to multiply our numerator by 3. Otherwise, we change the value of this expression. Now, our other rational expression, x squared plus x minus 1 over 6x cubed, we need to figure out how we can turn 6x cubed into 96x to the fourth. Well, the only way we can turn 6x cubed into 96x to the fourth is to multiply it by 16x. And if we multiply this denominator by 16x, we have to multiply our numerator by 16x. So let's do all this multiplication. My first rational expression will turn into 3 times 10 minus x all over 96x to the fourth. And then we're adding x squared plus x minus 1 times 16x all over 96x to the fourth. Now my first rational equation, I'm going to take this 3 and I'm going to distribute it inside. So we're going to have 30 minus 3x over 96x to the fourth. I'm going to add that to my second rational equation, except I'm going to distribute this 16x inside the parentheses. 16x times x squared would be 16x cubed. 16x times x would be 16x squared, and 16x times a negative 1 would be minus 16x. And this is all over 96x to the fourth. Okay, so now we have two rational expressions with the same denominator, and we're adding them, and we're going to add them just like fractions. So since they have the same denominator, we can just add across. This is going to turn into 16x cubed plus 16x squared. Now we have a negative 16x and a negative 3x, so this is going to be negative 19x. And then plus 30, and this is all over 96x to the fourth. This would be our solution.